Wait. Visible to all of you? Someone can speak? It is audible to all of you?
Yes, sir.
Okay, then we can start. Today we will discuss addition to carbon-carbon multiple bonds. Okay? So first is here simply addition reaction to unsaturated bonds. So how many types of addition is possible? Electrophilic, nucleophilic, free radical, different types of addition reactions are possible. So this is based on the substrate as well as substrate means main molecule as well as the reactant which is going to be added in the molecule. So here this is one example given below here. So addition to carbon-carbon multiple bond system, XY is the molecule is going to be added in this unsaturated compound. So two ways it can be added. One is that both both X and Y can be attached from same side. Okay, like this, because both are similar carbon-carbon bond. Other is that both are not same. Here one is carbon, one is another atom. So in this case, carbon hetero multiple bond is there. So addition takes place in different way. Now we can see how many types of addition is possible. Four ways of addition based on the reagents. One is simply electrophile, nucleophile, free radical, and XY addition. This is concerted. Sometimes it is also called cyclic transition state. Okay, so this is fourth type. So three are very common: electrophilic, nucleophilic, free radical. Some people classify this one is also part of among these, but basically this is a different kind of addition reaction. So all reaction takes place in two steps. Means first step is here, electrophile is going to attack on double bond. This is, so electrophile will where go? Electron rich center. Among these two carbon, which is electron rich center, this electrophile will go there. Electron deficient electron rich center, this electrophile will go there. And double bond, this will shift towards that carbon where this electrophile will go, and other carbon will be positive charge. In the same way, nucleophile will attack to either of this carbon or that carbon based on the nucleophilicity of carbon. And the same way free radical also. Here stability of the anion, free radical and carbocation is also responsible that which carbon is going to react with the electrophile, nucleophile or free radical. This is concerted cyclic transition state mechanism where this reactant and this alkene both will react simultaneously. There is no carbocation and carboanion formation takes place, no intermediate like that. Different kind of intermediate will form. So first we will see electrophilic addition reaction. All of you are knowing about electrophile. Electrophile means electron loving species. So how this will approach to double or triple bond and how it will give positive charge. It, if double bond is there or triple bond is there, the bond pair will move towards any of the carbon, and electrophile will go there and attack there, and other carbon will be the will develop the positive charge, and this will be the intermediate. Then that positive charge containing species or intermediate will be attacked by the nucleophilic species, and final reaction will be completed. The reaction may be uni, bi, or termolecular, means unimolecular, bimolecular, and trimolecular reaction is possible. This is the mechanism here. Here, this is a double bond. Electrophile is going to attack. So, electrophile is attacking on which carbon? Here, this is the electrophile generator, means from where electrophile is going to be generated. Okay. So, the electrophile will come from here. Two options are there. Either this can attack here or here. If this is going to attack here, it means this bond pair will move here and plus charge will be developed here. If this electrophile will attack here, then this bond pair will move here and plus charge will be developed here. Okay. So, as per this, electrophile is attacking on this carbon. It means this bond pair is moving towards this and plus charge will be generated here. Now, nucleophile is there. Nucleophile will attack here and reaction will be completed. So, two-step unimolecular open chain intermediate. This is the overall information about this reaction. And in another one, you can see here how this takes place. This molecule where nucleophile is there and electrophile is there. What is going on here? Again, this bond will attack, and in this case, how this is going to react? This will attack this carbon directly, or this will make a bond like this. Cyclic transition state will form. Okay, means this double bond is not shifting here or here. This bond is just donated to the electrophile. So it will be like this, and then nucleophile will come here because this bond is not broken completely. So now when this plus charge will be developed here, complete plus charge, here it is partial plus charge. But when this bond pair will be donated to this electrophile, then complete plus charge will be there. Then this bond, nucleophile electrophile bond will break, and this charge will be neutralized, and again this will attack on this carbon, and there is formation of this compound. So two-step, this is again two-step bimolecular. Two molecules are reacting here. Okay, here also two molecules, but this is not reacting as a molecule in this reaction. That's why this is unimolecular. Okay, here both are reacting as a molecule, this one and this one. That's why this is bimolecular. And transition state intermediate may be cyclic, as well as this can go this way also. There is also possibility to form this way. That's why it is written cyclic oblique open. Another way is that these two can react in one step. Simply this will come closer to each other, and immediately there is electrophilic and nucleophilic addition reaction. Now this addition can take place either syn or intertype. Mostly open chain intermediate favors syn addition, but cyclic intermediate favors more preferentially the NT addition. Okay. We can see here, syn addition, both will attack from same side, electrophile as well as nucleophile. Both are going to form a bond from same side. Anti-addition, electrophile from back side, nucleophile from front side. So both are in opposite orientation. So this is syn addition, this is anti-addition. How this attack will take place in electrophilic addition reaction? This already make a bond here. Then now nucleophile have two options. Either it can attack from this side because this is carbocation, that is planar in nature. So both planes are open for reaction, front side as well as back side. This is planar structure. So if this will attack from this side, then it will be anti. If you will attack from this side, this is syn, means open chain intermediate is there. So both types of products are possible in this case. This is product of anti, this is as a syn. So probability is equally for both product. Now you can see if this is exclusively only from this side, not from this side, then it is product is syn. So only the syn addition product is favored if condition is that this will attack only from this side. How, when it is possible, sometimes this bond breaking of electrophile and nucleophile bond will break and immediately this is very reactive. So from same side it will react. There is no enough time to go from to attack from other side. Now, this in this case, how this is possible? When cyclic intermediate formation takes place, electrophile make bond a cyclic transition state. Now, these nucleophile have only one option. This option is already blocked. So this option is open only. So this will attack either he and this carbon or this carbon, but from this side direction only. So this is only anti-product will form in this mechanism. And here in another one, you can see when this both are attacking simultaneously. This bond is going to take electrophile and this nucleophile is going to make a bond with this carbon. So simultaneous reaction is possible only when orientation will be anti. Otherwise, this will be sterically hindered area. So this is not possible that both can attack from same side because this molecule is also existing here. If this will also come here, there will be steric hindrance. So two-sided attack will be preferred and product will be the only anti-product. When this was first explained in 1911, McKenzie and Fisher addition in case of cyclic intermediate formation. Addition of bromine to maleic acid and fumic acid to give DL pair and succinic acid respectively. So this was explained in early of 20th century. You can see here that reaction. This is maleic acid, all of you are knowing, having double bond. C4 dicarboxylic acid having double bond. Okay. So how bromine will react? This is bromine. So bromine bond will break. Then there will be partial positive charge and partial negative charge on each carbon. Now this is having partial positive charge. So this is electrophile. Okay. So this will attack here. Okay. And now this is forming intermediate, not form intermediate cyclic transition state, not forming a single bond here. This will make a cyclic transition state intermediate. Now this side is blocked due to this bromine. This from this both the cases, both bromine will be in opposite direction, means anti-orientation will be there. So you will get DL pair. Okay, you will get DL pair. This molecule is cis molecule. Both hydrogen are same side. Okay, so cis will give DL pair. Okay, and same fumaric acid we can see in this both hydrogens are trans to each other. Okay, so now what will happen? Bromine can attack either this carbon or this carbon again and forming the cyclic transition state. Now this nucleophile bromine will attack either on this carbon or this carbon, and this will give meso product. Means there is a, you will get a mirror image in between the molecule here. If you will draw it properly, then you will get mirror image. But in this case, you will not get mirror image. In this case, you will get DL pair. Okay, means molecule will be here internal cancellation, here external cancellation will be there. Okay, so some molecule D and L both here, the whole one molecule will be optically inactive. Okay, both are optically inactive, but regions are different. Here internal rotation cancellation will be there, total and this carbon. Here both types of product, means if if one product having D chirality, other product will be L, so that will be equal that one. Okay, electrophilic addition, it has been found that the addition of bromine is not stereospecifically favoring anti-addition product. The anti-addition depends on the polarity of the solvent. Solvent of low dielectric favors 100% anti-addition. Solvent of high dielectric favors non-stereospecific addition. Water is having very high dielectric constant. You people are knowing some water reactions are also there. Now this is another example we can see here how bromine will react here. Again bromine is there, so what is it is forming non-stereospecific product. You are using cis or using trans, you are getting same product. Okay, how? Because intermediate formation, either you are going from this side you will get same, so product will be the similar product. Okay, this is intermediate carbocation will form if this halide will attack on in as we have as a electrophile, and it will attack either this or this carbon, then there is formation of carbocation. Another way is bromine can make a cyclic transition state, cyclic carbonium ion. So this will be donated to the electrophile. Another is that this is partially cyclic carbonium ion, means bromine will attack to one carbon, but partially it is forming a bond to stabilize the system by the lone pair of the bromine. So this is partial cyclic carbonium ion. So all these intermediates are possible in the addition reaction. Now we can see another example. This is cyclic structure cyclohexane having double bond, means 1,2-dimethyl cyclohexane hexene. So it will react with HBr. Then what is the possibility? Here both are attacked. Orientation is opposite, means they are trans to each other, means they are not binding from same side. Approach is opposite side, that's why their orientation is opposite and they are trans product. Now another reaction is hydration reaction. Again OH and H is there, but in this reaction both products are forming, trans as well as cis. But in this case to form, it means if only trans is going to form, it means intermediate is cyclic transition state. Whereas if both are going to be formed, it means intermediate is carbocation. So that will be planar and there both side will be open for reaction for second step. Okay. So both cis and trans product forms. Here DBr is going in place of HBr, DBr is used. In DBr, you can see product is 1-bromo 10-tetroacetophenylthrene, means both bromine and D both are attacked from same side. Here, if you will use HBr, it is difficult to differentiate that which H is from your reactant. That's why DBr is used to study the reaction. So DBr, both deuterium and bromine is binding from same side. Okay, so if they are binding from same side, what is the meaning of this? It is the meaning of this that this will not form cyclic transition state either this point, or it is forming carbocation which will be favored if both are attacking from same side. Another is that if bromine will attack first, then which side is open? That is another point. Okay, so that way it can be discussed how deuterium and bromine will be attacked. So bromine deuterium bond is going to break same time there is formation of this carbon deuterium bond, and so both are attacking on same side. That is the point. That's why they are there is cis addition, not trans addition. Now we will see nucleophilic addition reaction. Nucleophilic reagent approaches the double bond, triple bond substrate to give negative intermediate, means carbon ion will form, and the positive intermediate is attacked by the electrophilic species. Okay, then first electrophile will attack. This addition reaction will be favored when the substrate has an electron withdrawing group. Okay, this is a mechanism. So nucleophile will attack. In previous example, first electrophile while attacking, here nucleophile will attack. Then this bond will move here and formation of carbon ion. Now electrophile will come here, make a bond. When the substrate contains a good leaving group, substitution reaction is more favored. Okay? When the substrate contains a good leaving group, substitution reaction is more favored. Okay? When electron withdrawing group is present in the substrate, addition reaction is more favored. You should remember this. When substitution and when addition will be favored. When the substrate contains good leaving group, substitution reaction will be favored, but when electron withdrawing group is present in the substrate, addition reaction will be favored. This is nucleophilic addition. We can see in another example. Here nucleophile is going to attack here. Now there is shifting of this bond to this, and this carbonyl double bond will form a enolate ion. So this enolate ion will stabilize the system by conjugation. So intermediate is little bit stable. Okay. Two intermediates two resonating structures are possible. Now in next step, electrophile will attack. Where it will attack? This oxygen or this carbon? You have to answer it. So now product will form. So in this case, some electron withdrawing group will be there, and that will promote addition reaction. For example, you can see CHO, COR, COR, CONH2, CN2, COR. Yes, so 2R, etc. Michael reaction is a type of nucleophilic addition reaction. In this reaction, we can see this is the electron withdrawing group, cyno group. In previous we have said that Z group, and this is double bond. Okay. Now this is nucleophile. Okay. So now this will attack. This will attack on this carbon. This bond will move here. Anion formation takes place. Okay. Now this anion is there. Now electrophile will come. And this will attack to this carbon anion, and this will form a product like this. Here, electron either nucleophiles may be any of this, okay, Z alkyl, aryl, hydrogen, or any other. The nucleophilic addition is non-stereospecific and stereoselective. What is stereoselective? What is stereospecific? Okay, you will are knowing, I think. If you have any confusion, you can ask. The product are formed based on the favorable conformation assumed by the carbon ion in this nucleophilic addition reaction. This is Z isomer, this is E isomer. Now nucleophile will attack. Nucleophile attacking on Z isomer as an intermediate, okay, this is attacking from this side. But if it is attacking on this carbon, E isomer and same type side, okay, carbon ion will be like this. So in these two example, you will see what is the product. Product is same, okay. If product is similar, it means intermediate is forming in such a way that product is forming from example. So this is stereo selective or stereo specific. You people have answer here. If you are knowing stereo specific, you are knowing stereo select. Stereo selective depends on product. Stereo specific means depends on the stereochemistry of a starting compound. So this is stereo selective nucleic addition reaction. Again, some reagents like or trimethyl CSD to trans-ethyl butanoate shows anti-addition product without nucleophilic triple bond still anti-addition product addition. Now we can see this example bit. So this is another starting what will form this D and OET minus. So D plus is electrophile, this is nucleophile. Okay, so nucleophilic reaction, so this will attack here, then this will form a carbon ion and deuterium will bond here. Now we can think why this ethoxide ion is nucleophile is attacking here, not here. What is the problem? How this bond is moving here due to this group. This is a if this bond will by this group. That's why this on this carbon. Now we will see free radical addition. So free radical addition is a type of chain reaction. All of you are knowing since long back how this reaction takes place. There is either light or heat is required in free radical reaction to form some free reaction of the free radical addition reaction. So initiation, propagation, and termination. There are three steps in this reaction. Initiation is by formation of free radical. Now that will react with the reactant and form an intermediate radical. Now that radical will propagate the reaction. Now propagation will be terminated so initiation, then there is formation of interaction, and in last there is termination of the reaction when all radical will react with each other anyway, and that reaction will be terminated. All neutral molecules will be delivered. How we can see some reactions? This is non-stereospecific. You should remember which is stereospecific, which is not stereo. Reactions are mostly stereoselective. Let us look at some example here. This is 1-bromocyclohexene. HBr is going to react with this. So, how this will react? HBr will give Br minus nucleophile H plus electrophile. So, first step, there is formation of free radical. HBr will give free radical. Now this double bond will also generate free radical, one electron this side of bond pair, one electron this side, and this one electron will react with the free radical present in the reaction mixture. So this will react with this and formation of this product. Okay, and if simply propyne is there, again reaction will be similar. There is formation of free radical as well as there is formation of one bond with among this hydrogen and bromine, and it will form a intermediate free radical. Then again this will react and this will form a product. Free radical reaction become stereospecific cases, and this will be disappeared at room temperature. Okay, means at room temperature, if you are going to do, then there is possibility of stereo specificity, but usually these are stereo selective reaction. So this is due to the formation of breezed intermediate. If double bond is there, bromine is there is chance of formation of breeze head intermediate like this. As Br is there, bromine is going, bromine will form a cyclic transition state or breeze head intermediate will form. And finally, in last step, hydrogen, these are these carbons from the back side, and there is formation of going to be bind, and if bromine is going to be added, then also bromine can bind from this side or this side. So usually reaction takes place, so there is formation of this mesomerisome. this is the alkene, and this is going to react electron, and this is electrophile, this is nucleophile. So four center transition state. These two, someone is not able to join. Why? Who is not able to join? Okay. So cyclic transition. So this is the reactant alkene, and this is the source of electrophile and nucleophile. So this is one center, this is another, this is nucleophile, this is electrophile. So there are four center in transition state, and finally they will form a product. And if this is diene, this is enophile, if these are going to react, then there is formation of six center cyclic transition state, and that will form a product. And we call it addition to conjugated system. Addition to conjugated double bonds, 1, 2, and 1, 4 addition. What is 1, 2 addition and what is 1, 4 addition? We will see. This addition reaction goes via open chain or cyclic intermediate. Sometimes the reaction is a so either both here, or one will bind here and one will bind here, and double bond will be here. So this was possibility. So if this is going to react here and this is going to react here or here, two possibilities are there. So if electrophile will make a bond here, this bond is moved here, plus charge is already here. Okay. If nucleophile is binding here, this bond will move here. If nucleophile will bond here, then this will be isolated double bond. It will not take part in reaction. But if this will attack on this, then this bond will move here. Means this is not isolated and this will take part in reaction. So here in this molecule, this double bond is isolated, not taking part in reaction. But in this, that double bond is taking part in reaction. So this is a conjugated system. Both double bonds are conjugated with each other. Now, what is the mechanism? How this will take place? We can see here 1, 4 and 1, 2. In 1, 2 addition, electrophile, nucleophile. Electrophile attacks, then formation of carbocation, nucleophile attacks, and there is formation of 1, 2 addition. In this case, there is attack of electrophile, form a bond, then nucleophile will attack on carbon number 4, and there is formation of 1, 4 addition reaction. Thermodynamically controlled, 1, 4 is thermodynamically controlled. Why? Any one of you can think about it. Because this alkene is more stable compared to this alkene. Why? Because this alkene is more substituted. This is thermally more stable. So this will be thermodynamically controlled reaction. In this case, this is kinetically controlled. It means reaction barrier, energy barrier is less in this reaction, but product is not very stable. You can see here. If activation energy is here and this is intermediate, 1, 4 intermediate, 1, 2 intermediate. Up to when electrophile is going to attack. Both are same. Difference is there. You can see here. This step was same. Electrophile is making bond here. Okay. So that was the first step. Second step, nucleophile will attack. So there is difference. So energy also you can see here there is difference. So in 1,4 addition reaction, energy barrier is high, and 1,2 addition reaction energy barrier is low. So this 1,2 addition is kinetically controlled, but it is more stable. 1,4 is more stable. You can more stable, but activation energy is high. So this is thermodynamically controlled. This is kinetically controlled product. Now we can see here addition to conjugated systems, formation of some uncommon intermediate during the addition mechanism. How we can see here, in previous slides we have seen that electrophile was attacking on carbon number 1 or 4. Now we can see if electrophile will attack on carbon number 2, then this nucleophile come at here. Why this will be least favored? Because this carbocation is going to be formed. If this will attack on this, carbocation will be here. Here this is tertiary carbocation, but here it is not, because these are hydrogen. So this will be the primary carbocation. That will be least stable. So less probable. Product is least in amount. Another example we can see bromine is there. If bromine is going to react, so bromine electrophile will attack here, formation of cyclic transition state, more and less probable to make a cyclic transition state like this. Okay, because this is far away from this bromine, so difficult to make a bond there. Now we can see nucleophilic addition to conjugated system. How this nucleophilic addition takes place means, for nucleophile will attack. So nucleophile will attack if here there is formation of anion here. Okay. So either it will be here or anion can be here also. If this bond will move here, this side, and this bond can move here. So there is formation of this one, and final step, this will be the product. In this one, nucleophile is attacking here. Next step, carbon ion is electrophile is attacking on this carbon. This carbon ion is there. Two options were there. Either an ion will be here or here. So both places they are attacked. Now in next step, finally electrophile is going to attack. There for electrophile either C4 or C2. So they are forming the product. Now we can see here also how free radical addition is possible in conjugated system. So first free radical will form here, and this also will form free radical possibility. One electron of bond pair here, one electron will, and these one electron from this nucleophile, one electron from this bond pair make a bond with the nucleophile or okay, anyone. So if electrophile is forming bond, so this bond will form and this will generate C4 C4 free radical intermediate. Now sufficient is influenced by the nature of substituent present. As I told earlier also, so this is a group which is attached. So if electron donating group is there, OH NH2, NHR, SH, R, Ar. So addition reaction, electrophilic reaction will increase, nucleophilic will be decreased. If electron withdrawing group is there, electrophilic will be decreased, nucleophilic will be increased. The effect of substituent is so great that there is a generalization as given here. Simple olefin do not react by nucleophilic mechanism, and polyhalo or polysine olefin do not react by electrophilic mechanism. You should remember this is very important. Simple olefins do not react via nucleophilic addition, and polyhalo or polysine olefin do not react through electrophilic mechanism. What is difference? Nucleophilic mechanism means this is nucleophile, this is electrophile. Nucleophilic mechanism, it will attack first. The electrophilic mechanism, this will attack first. So reactivity of the substrate towards electrophilic addition reaction, we can see how bromine is going to react. So how bromine will make a bond? This can attack this side, either this carbon or this carbon. If it means power minus 7, not high. This is very less. So it means electron withdrawing group is there. Reaction is slower and slower. Okay. So as you have seen, if electron withdrawing this kind of there, then nucleophilic reaction will increase, not electrophilic. Electrophilic will be decreased. So G, if this is there, nucleophilic reaction will be increased, and but it will be very slow. In hydration reaction, we can see if there is G is hydrogen and C is 1,000 times more. It means this will be electron donating group, so electrophilic reaction will be favored in this reaction. The reactivity of alkene and alkyne substrate. Alkene more prefer to show electrophilic addition, whereas alkyne show nucleophilic addition more readily. So reactivity of alkene is higher than alkyne. The pi electrons are less tightly held by the carbon due to the longer carbon-carbon distance in alkene. So it is not harder for the electrophile to pull this pi electron. Whereas this carbon-carbon bond, this is shorter than this one. So pi electrons are more tightly held by the carbon due to a smaller carbon-carbon distance. So it is harder for the electrophile to pull the pi electrons. And cyclic to intermediate, that is anti-aromatic in nature and less in stability. What is anti-aromatic? Means number of pi electron will be in aromatic it is 4n plus 2 pi. Okay, but in this case, this is conjugated system is there. Okay, but 4n plus 2 is not followed here. Here only 2 pi electrons are there. So this is not aromatic in nature. The reactivity of alkene and alkynic substrate have been observed as follows. The free radical addition can occur in any type of substrate. The nucleophilic radicals behave like nucleophiles, and the rate is enhanced in presence of electron withdrawing group, as we have seen. The reverse is true for electrophilic radical. The deciding factor is the presence of a radical initiator. Initiator will promote the reaction. These are some examples how this will form. S plus Br minus S plus Sr minus. If initiator is there, then it will form S free radical, Br free radical, S free radical, Sr free radical. Now theory of reactivity. We can stop here. Again, we will discuss tomorrow. Any one of you? Hello? You can mute yourself, unmute yourself. We are going to stop here. Again, we will start from this slide tomorrow because I was thinking to finish, but it will be very heavy load for you, all of you. So from here again, we will start tomorrow same time. Okay?
Sure, sir.
No.
Okay, sir.
Okay. Tomorrow around the same time. I will inform you.
Okay, sir.
Okay.
Okay, sir.